So now let's take a look at Matplotlib. So Matplotlib, as I mentioned before, is a Python package that we use for managing figures and creating plots. So we already loaded the pyplot from Matplotlib as a PLT. So PLT. And what we can use here, which is the function that we typically use for initializing a new figure, is the subplots. So if this figure, if we look inside with Shift Tab, we see that the first two arguments are number of rows and number of columns. So for instance, if I want to create a figure with 4 axes, a 2 by 2, this is all that I need. So if I run this, it generates this axis, this figure with 4 axes, with 2 columns and 2 rows. In this case, we just want 1 column, 1 row. So let's do that. So this generates 1 axis within 1 figure. And as you can see, the output here, the first output is a figure handle, and the second output is axis. So we typically name those fig and ax. So this will capture the output. So figure is the figure handle and x is the axis handle. This figure is a little bit too big, so if we want to change the size of the figure, we can do fig size equals, and then let's do say 2 by 5. And if I run this cell, it's now a 2 by 5 figure. That's not looking good, so let's do a 5 by 5. Yeah, so this is more like what I kind of want for this plot, so I'll keep that. So let's start adding elements to this figure. So the main control to add elements to the axis is this axis object. So this axis object has plenty of functions. It has this plot function, it has a scatter function for plotting scatters. In this case, I want to use a scatter, so let's go ahead and use that one. So scatters will take some data for the x-axis and some data for the y-axis, and we have some other controls on how it looks like. So let's start adding some data. So the data for plotting could be anything. It could be lists, it could be in NumPy arrays. Because we typically store our data into data frames, let's just use the data frame. So as you might recall, our data frame has some copper variables. So this is going to be our x-axis. And then for the y-axis, I'm going to use the other variable that we have, which is called element A. And that's all for now. So let's take a look at how it looks like right now. So yeah, this is our plot. It has some scatter. We know the x-axis is the copper. We know the y-axis is the element A, but there's no labels yet. I'll get into that. The other thing that you might notice is that it shows this stuff on the screen, and that's just the output of this call. Because we're not capturing that, it always shows on the screen. So one trick that you can do to avoid showing this, because this is kind of distracting, you can do underscore equals, and this is making a assignment, but it's actually just discarding the output, but it doesn't show on the output. So it makes for a more clean cell. So one thing that I would like to change on the looks of this figure is the scatter size. The markers are too big. So let's make it a little bit smaller. So the argument for that is s. S equals 3, we'll change the size to 3. So 3 looks better, so I'll keep that. So now let's just start configuring this figure and make it look better. So first of all, we know that the x-axis is copper because that's what we used, but the figure doesn't indicate that. So let's start adding some labels. So for instance, we can add x label by using the function setXLabel. And let's just say this is copper. So if I run it now, we have added the label copper. And of course, we get the output here because this is now the last line. So you can keep doing this if you want, so to avoid all the outputs. So we know the y label, the y-axis is element A. So let's do that. And another thing that we might want to add is a title, set title. So this is a scatter plot. So it's looking much better now. We have a title, we have labels. The limits for the axis are kind of off because we know copper can't be negative. We know element A can't be negative. So the last thing I want to do to this figure is to, well, set the X limits and set the Y limits as well. Because I only want to, so to set the limits, we can provide two numbers, the lower and the upper limit, but they're all optional. So if we just want to restrict the first one to be 0 and not the second one, so let this be dictated by data, then we can just use known. So if I run this now, the figure looks much better, and this might be just the final version of the figure that I want. So many Python packages leverages the other packages. So one example of that is Pandas data frames. So for instance, we can use Pandas data frames to create some predefined figures. So let's demonstrate that. So first of all, I'll create a figure with two axes. So it's going to be one row and two columns. And the figure size now kind of have to take into consideration that we are going to have two columns. So the length should be greater than the height. So yeah, this looks okay. So let's start adding elements to this axis. So if I look at the axis now, axis is an array of two axes, two objects that we can actually access by indexing. So this is the first axis and this would be the second axis. So let's start adding some elements. So for instance, I can access the first axis with the index 0, and to this one, let's do df, and I know one of the functions that Pandas data frame has is hist, which stands for histogram. And we want to see the histogram for copper. And if I look inside this function with Shift Tab, we can see that we can provide a axis to this function so that it draws the histogram on our selected axis. So let's do that. And just to demonstrate another option, let's do grid equals false, and I'll talk about what that is. So if I run this now, this just added the histogram of copper to the first axis. So let's add more things. So now what I want to do is to go into the axis 1 and add element A to that axis, and grid equals true. Let's run that. So you can see now what grid's doing. So grid is adding grid lines to the plot. So there are many options within these functions to customize the plot, right? Other thing that I can do is change the color to say gray, and this will change the color of the bars to gray. And just as we did before, we can do set X label and set Y label, and we can do here, this is element A, because we want to set the X axis to element A, and the Y axis, this is a count, so it's the number of data. So let's do count, and let's copy it over here and change it to copper. So with that, I customized my figures to have the Y label, X label. I changed some colors and some properties of my figures. So that's how kind of data frames can use some elements of Matplotlib. So it's one package making use of elements from other packages, leveraging other packages